Good morning everyone. So today we're going to look at the fourth mechanism, which is known as hydrohalogenation of alkene. It is a type of reaction for electrophilic addition reaction. Hydrohalogenation, from this word we can see that hydro means H, halogen means anything that is from group 17. Halogen, for example, Cl, F, Br. In this mechanism, we are going to add hydrogen and any halogen into alkene in order to form haloalkane. The general mechanism for this is when you have an alkene, when you react with HCl or HBr or HF, you are going to get a compound like this, where you add H and Br. For this case, H is going to be the electrophile, Cl- is going to be the nucleophile or any halogen, Br- or F-. And in this mechanism, we are going to add electrophile first, the less awkward one, followed by nucleophile, which is the more awkward one. So you may wonder, what should I add first? Where should I add the electrophile and where should I add the nucleophile? What if you have this one react with HCl? So before we see at the difference, let us look at one rule which is called as Markovnikov's rule. It is applied when you are breaking the double bond and you want to add something. It is the opposite for Say-Zev's rule. Say-Zev's rule says that when you have more alkyl, you will be more stable when you are forming double bond. But for Markovnikov's rule, it is the opposite, where if you have less alkyl, you'll be more stable when breaking the double bond. So applying this rule, let us look at this example. So when you are breaking the double bond, you are going to first add the electrophile, which is H+. So you should add here or here, or here. Okay. So in this case, you are going to add to the right hand side, which is here. Why? Because if you see here, this is a primary carbon, but for this one, it's a secondary carbon. So we are going to add to the last alkyl group, which is this one. If you are going to add to here, which is the secondary one, it will be another rule called as anti-Markovnikov's rule. And the reagent used is HBr, H2O2, hydrogen peroxide. In hydrohalogenation, we are going to only apply Markovnikov's rule, but not this one. So after you add the electrophile, you are going to add the nucleophile, which is Br-. And Br-, you should add to the more alkyl group. Now, let us look at some of the examples. When you have this compound react with HCl, what will it form? So, as usual, we are going to write out what should we achieve, what is our aim. So first, we are going to add H, which is the electrophile, followed by Cl-, which is the nucleophile. So as you can see here, HCl, this one is a partially negative atom because group 17 halogen, they are highly electronegative. And hydrogen is going to be the partially positive one. And here you have the negative pi electron on alkene, which will make this as the nucleophile, because it is electron rich. So the first step, what it will do is that the nucleophilic pi electron is going to reach to the hydrogen, which is the electrophile, which lack of electron. So after the nucleophilic pi electron reach to hydrogen, the hydrogen will break one bond because hydrogen cannot have two bonds. It can only have one bond. So the remaining bond will break and the electrons will go over to Cl. And the resulting compound will be like this. Cl will be with oxidation state of -1 because initially it has 6 electrons. When you add 2 more electrons, it is more than 7, it will be -1. And the nucleophilic pi electron reach to H. It is going to add H into this and break the double bond. But should I add at the right hand side or the left hand side? For this case, it is right hand side because here you have primary carbon, but for this one you have tertiary carbon. According to Markov-Nikov's rule, here will be the one which we will favor. So the resulting compound is like this. Once you form carbocation, you must consider rearrangement. But for this case, there will be no rearrangement because here is already tertiary carbocation, which is the most stable one. Next, remember, we have already added H. The next step, we are going to add Cl. So, the remaining Cl, which is partially negative, is going to attack the partially positive carbocation, and the resulting compound will form this. This bond is formed when there is 2 electrons. Lastly, for these 2 steps, you must remember to write whether it is slow or fast. Slow because it is initially from stable, it becomes unstable. So it is slow. But if it is from unstable, becomes stable, it wants to become stable. So it is a fast reaction. Once you have added Cl, this means that our aim is achieved and the mechanism is completed. Next, let us look at the second example, where you have this compound react with HBr. What will it form? Always remember our aim, which is first add the electrophile, which is H, followed by halogen. For this case is Br. First of all, HBr, this is a partially negative atom, this is a partially positive atom. And for this one, there is a double bond, which means that this is a nucleophile because this is electron rich. The negative pi electron on alkene is going to be a nucleophile, and this nucleophilic pi electron is going to reach to hydrogen, which is electrophile. It is electron poor. Next, when this H is more than one bond is going to break, and the electron is going to the adjacent atom, which is Br. The resulting compound will form this and Br-. Next, when you have carbocation, always consider rearrangement. For this case, rearrangement is needed because this carbocation, this is a secondary carbocation. It is attached to 2C. But for this one, this C, it is attached to 3C. So this is a tertiary carbon. This will be a more stable one. So what it will do is that 1,2 hydride shift will occur, and there will be no 1,2 methyl shift because there is no CH3 occur. There is no CH3 that is available, but there is only hydrogen. So 1,2 hydride shift will occur to make the carbocation to be a more stable one, which is a tertiary carbocation. Next, after rearrangement, the Br minus, which is a partially negative atom, is going to attack the partially positive carbocation, and the resulting compound will form this, where you have already added Br. Once you have achieved adding H and Br, this means that all our steps are completed and the mechanism is completed. Lastly, let us look at this example where we have this compound react with HCl. Again, first HCl, this is a partially negative and this one is a partially positive. And since there is double bond, this means that this is a nucleophile because it is electron rich. And for this one, it is going to be the electrophile because it is electron poor. The negative pi electron is going to reach to H, which is partially positive, and since H can only allow one bond, the remaining bond will break and the electrons will go over to Cl. The resulting compound will form this and Cl minus. Once you have formed carbocation, consider rearrangement. For this case, rearrangement is needed, and it happens between here and here because this one is a secondary and for this one it is a tertiary carbon. This one is a primary carbon, so we do not consider this one. 1,2 hydration is going to occur because there is no CH3 for this carbon, but there is only H. So 1,2 hydration is going to occur here and the resulting compound will form this. Remember, initially you have already added H, but the next step we are going to add Cl. So the remaining Cl minus, we're going to attack partially positive carbocation, and the resulting compound will form this, where you have already added Cl. Lastly, remember about the slow and fast reaction. The first step is a slow one, but for the second one is a fast one. Because first step, it is from a stable one becomes an unstable compound. But for this one, it is a fast reaction because it is from unstable ones become a stable one. So for the steps, you must write slow or fast reaction, and then when there is a lone pair or bond attack H, H must protect because H can only be one bond. If it is over duplet rule, which means it is over one bond or two electrons, one bond will break, and the electrons will go into the adjacent atom. That's all for this video. Thank you.